Excuse me. Ito po ba, tama lang sa screen?
Yes, sir. Okay naman.
Okay. Sige po. So today, I will be presenting on the power quality analysis. So we will be discussing on the overview to define the basic principle of power quality analysis, its effects on our system and mitigation techniques, and the monitoring strategy on how to use those informations that we gathered during the power quality measurement on improving our facility. So I am the presenter. This will be the topic. Coverage ng topic. Yan. So the outline of our presentation today is are the following. So we will study first the ideal condition. What are the power quality issues in our systems that we need to address, we need to monitor, and we need to check for improvement. Then how do we measure the power quality? So what are the instruments that are being used to measure the power quality? And how do we generate the power quality reports? Then fifth, we have the techniques in mitigating power quality issues. So if in case we find some power quality issues in our system after the measurement, so how do we mitigate them and how do we address them? And finally, we have the power quality standard reference. Then in our last presentation, we'll be showing an short example of power quality analysis done on a certain facility. So what is power quality? So when we say a power with a good quality, all the factors, basic factors of our system are on ideal conditions. So for example, the voltage and current waveforms are relatively in phase with each other. The distortion is zero, or there's no distortion or flicker. The load is balanced with respect to each other. The angle of the phases of our system are also balanced, equally distributed, 0, 120, and negative 120 degrees. Then the frequency is perfectly 60 hertz. And the magnitude of the voltages are perfectly equal. So those are ideal conditions of the power system. Now, since we have a very large system comprising of many loads with different characteristics, those conditions are relatively not ideal. So because of this, we have what's so-called power quality issues or low power quality in our system. So what are the indicators of an ideal system? Now, if the system is ideal, the current and the voltage are in phase. The phase shift is exactly 120 degrees. The load is balanced. There is no voltage and current distortion in the system. The impedance of the source is zero, and the actual frequency is the same as the nominal frequency. So ito yung ideal condition. So walang problema sa system. But this is not the case on the actual condition because of our varying loads. So in most cases, almost all of the time, yung power natin sa system is not in good quality. So meron tayong low power quality in the system. So what are the factors and indicators that we can say that our system has a low power quality? So number one, current are not in phase with the voltage. So there is a power factor due to some load characteristics. Phase shift not equivalent to 120 degrees with respect to each other. Load is not balanced. There is distortion for the voltage and current. The source impedance is not zero. Actual frequency is not the same as the nominal frequency. So that's the problem of our system on the actual condition. So what are the effects of having a low power quality? So number one, if it is severe, there will be an increase in utility bills. So lalaki yung one of the factors na affect niya. It could be increase in utility bills because of heating or other effects. It causes damage to the critical power equipments, especially yung mga electronic equipments natin. Then this will result in high production cost because you need more power. For example, if it is power for pumping water, you need more power for pumping water. If there are power issues, power quality issues, then there will be higher downtime. If there are problems that may arise that will affect the entire system performance, there will be a high maintenance cost. Electrical utilization equipment will age fast because of those problems that affects the performance, and there could be a frequent replacement if those issues are not addressed properly. So ito yung mga factors na tinitingnan natin yung having a low power quality in the system. So what are the power quality issues that we are going to look into in our system? So basically maraming mga factors yan. But we have to address them and then define them independently because these factors will affect the system in a different way. So meron tayong 4 na category. So these issues are the following. The power interruptions. We have the under voltage, over voltage, sags and swells, flicker, transient and noise, power factor, balance loads, and hihayat ko lang ito. Okay, di mo wala. Okay, so we have the balance load and harmonics. So we will be discussing in the broad concept of all of these issues because each type is actually a one whole topic, no? Kaya kailangan natin patapalan natin i-discuss lahat ng ito. Now, for us only to be aware of what our system is undergoing every time we operate. Yeah. Okay, so let us define power interruption. The most simple type of power quality problem, of course, in the power delivered to an electrical load is basically goes away, or meaning mawala yung power supply natin. So this is called power interruption. So the different types of power interruption classified according to their duration. So ito yung example ng representation natin how an interruption will happen. If the voltage will be reduced to only 10% for a short period of time, a medium period of time, or a longer period of time, that is considered as an interruption. So if it is only between 0.5 to 3 seconds, temporary, 3 seconds to 1 minute, and it's just sustained, momentary rather, and the other one is a temporary interruption if it is from 3 seconds to 1 minute, and it is a sustained interruption if it is completely out of supply for more than 1 minute. So it is considered an interruption. So an interruption, it would be a partial decrease of the voltage or full decrease of the voltage to 0 volts. So what are the effects and causes of this power interruption? It could be a lightning strike. It can cause a large swell or sag of the power system. It could be utility switching. There is a load, big loads that is being supplied or connected to the system. Or it could be a physical damage to power lines. For example, meron tayong insulation failure. So nagkaroon ng pagkaputol ng wire. It could be an interruption also. Then lastly, we have the human error. So what are the effects for having this interruption to occur in our system? So, number one, it could lead to the damage of electrical equipment. Second, it will result to equipment stress. So, pag palagi mayroong brownout, babalik na naman. Interruption, babalik na naman. So, our equipment, especially those that are having moving parts, so ma-stress yun. It could lead to mechanical damage. Then, it could also result to a short circuit if the damage will cause the linking of one line to ground or 3 lines or 2 lines in any case. Then, the last one is equipment damage. So, these are the effects of power interruption. Okay. So, the second type of power quality problem, of course, when the voltage of the load drops below the minimum rated voltage. So, this is what we call the under voltage. Okay. And the other type is the opposite of this is the over voltage. And related to each of these are the sags and swell. So this is the second classification. So the second type of power quality problems occur when the voltage of the load drops below a minimum rated voltage or climbs above the maximum rated voltage for some period of time. So depending on how long these conditions last, it may be referred to as an under voltage or an over voltage and sags or swell. So we have here a diagram illustrating how this different system voltage variation affects the system. Ito halimbawa sa kabila sa under voltage, so bigla nang bababa siya for a certain period of time for a voltage value below 90% of the nominal rated value. So if it is 90%, under voltage na yan. On the other side naman, if it is more than 10% or 110% of the rated voltage value, it is already an over voltage. Pero sana natin mandate ng distribution code para sa mga distribution utility, 10% plus or minus 10% na voltage variation in the system is considered within the limit. So, papasada pa naman. Pero with regards to the load side, load sa atin, sa mga consuming devices natin, this 10 plus or minus 10% is already giving an adverse effect to our equipment. Kaya hindi magandang magkaroon tayo ng ganitong condition. Okay, so if it is an under voltage, it happens when the voltage drops below 90% of the nominal RMS voltage and stays at that level for more than 1 minute. So the term brownout often refers to an intentional or unintentional drop in the voltage in electrical power system. So, under voltage pala, definition yan, nagkaroon tayo ng under voltage if it is below 90% of the nominal value of the voltage. So, sa kabilang dako naman, if it is an over voltage, more than 10% of the nominal. So, if it happens 1 minute or more, these conditions could be an under voltage. If it's below 90, over voltage if it's above 110%. So, what about sag and swells? Now, the sags, the same characteristic as the under voltage, only that there is a very short period of time for that variation of the voltage. So, the sag occurs when the RMS voltage decreases between 10% to 90% for a duration of a half cycle to 1 minute. So, if it is pala less than 1 minute, if this voltage fluctuation happens within 1 minute, isang 1 minute that is around half cycle to 1 minute. Half cycle, we know that 1 cycle is 1/60, or that is 16 milliseconds. So half the cycles is 8 milliseconds. So if this condition of the voltage variation could drop between 10 to 90% within 8 milliseconds, we call it sag. So very abrupt lang, siguro nagkaroon ng switching. So, yung bababa konti yung yung system voltage. So it would happen if there are large load that is being connected to the system. So usually, doon siya mag-appear. Then the swells, on the other end, bigla namang umakyat ng voltage more than 110%. So the same cycle, it happens with a time duration or time period between half cycle to 1 minute. So if it's less than 1 minute, karoon lang variation ng voltage more than 110%. That is what we call the swell. So biglang lumaki. This will happen especially if we have large load being removed from the system. Or kung mayroong lightning strike, kung mayroong lightning strike, biglang aakyat yung mga voltage values ng ating system. Or kung karoon ng load at tinanggal na malaki, it will result to a sudden rise of the voltage to more than 110%. But a very short period of time, within half cycle to 1 minute. So that is what we call the swells. So the characteristic in terms of magnitude, pare-pareho lang sila noong under and over voltage itong sag and swell. So the only thing that differs from these factors are the time in which this variation occurs. So if it is more than 1 minute, under voltage or over voltage, if this is less than 1 minute, it is sag or swell. These are just temporary, pag sag or swell pala is just a temporary fluctuation in the voltage for a time duration within 1 minute. Okay. The fourth type of our power quality issues are the flicker and transient. So what is a flicker? So it is a repetitive voltage reduction lighting circuits that can be detected by the human eye. So bigla lang, makita natin sa ilaw, for example, na fluorescent lamp, parang sa Bisaya pa yan, tawag namin, mag-ipat-ipat. That's flickering. It is a phenomenon that is known as flicker. So bakit nagkaroon ng flicker? There is a small variation in the voltage for a certain period of time, usually less than 1 minute. Okay. So the term flicker refers to a very specific problem related to human perception of light produced by incandescent light bulbs, not necessarily general voltage fluctuation. So, maliit lang man yan na mga voltage variation, it's not necessarily a general voltage fluctuation. Flicker lang because of the small changes in the magnitude of the voltage for a certain period or unit of time. So transient on the other hand, yung biglang merong notches doon sa ating wave. So this is different from the flicker. Okay. Then the other one is the noise disturbances of the signal. Ito yung marami ng combination of flicker and notches doon sa ating power system. So what are the some common source of flicker? The flicker includes arc welders. So pag magkaroon ka ng welding machine, so biglang pasok din, short circuit yun eh. Pag biglang pasok din, tapos tanggalin mo na naman, that will create the condition of the flicker. So electric boilers, also industrial motors, especially if it's slightly loaded to the system, laser cutting machines, or any type of laser cutting devices, photocopying machines, zoom mills, and X-ray machines. So these are the common source of flickers. Okay, the third type is we have the transients. It occurs when the spikes are superimposed on a voltage or current sine wave, so ranging in amplitude from just a few volts to several thousand of volts. So ito yung delikado, no? Kasi transients cannot be seen. It is very fast. It acts in a nanosecond. And if the magnitude is severe or large, it can damage the insulation. So it can reach from a few volts to several thousand volts. So ganun kalaki yung transient. And imagine how damaging its effect would be. So lighting and utility switching typically cause high energy impulses transient of short duration, while electronic devices such as the VFDs and switching inductive loads typically cause low energy transient continuously. So ito yung mga sources of transients. Yung switching devices na electronics, then the BFDs. Kasi natin yan repetitive switching. They are using the IGBT, so switching operation ang basic principle on how to operate the IGBT. So because of that switching, it affects the entire performance of the system, and it can create damage if not addressed, or if not kahit i-limit man lang to a safe value. So what is an impulsive transient? So the impulsive transient will last anywhere from 50 nanoseconds to 1 millisecond. So maliit lang. But the damaging effect will be dependent on the magnitude. So kung malaki yung magnitude, it could be damaging. The other type transient is oscillatory transient. So it would last anywhere between 0.3 milliseconds to 5 microseconds. Now, oscillatory, parang repetitive, no? Repetitive. Now, pagka ganun ang transient mo, between 0.3 milliseconds to 5 milliseconds, tapos pabalik-balik at same magnitude, that is oscillatory. Okay. Third type, we have the noise. It refers to the unwanted high-frequency oscillations. Usually ito nasa related to harmonics. High-frequency oscillations that are superimposed on alternating voltage or current sine wave. So this phenomena is usually intensified by improper grounding and is capable of disrupting electronic devices such as computers and programmable controllers. So pagka, siyempre ang system kasi natin is full of different equipment na nakakonect. Now because of that, having different characteristics, different behavior ng load, it can create some unnecessary waves na papasok sa system natin. Now, proper grounding, usually we eliminate those, pero pagka hindi maganda yung grounding, it can allow, our system will allow the passage of those noises to our system. Hindi siya maitapon sa ground properly. Because of that, this will affect the electronic devices. So doon naman siya mag-cause ng problema doon sa mga electronic devices. Example, sa mga computers natin, pagkakaroon ng mga errors sa electronic equipment na nag-operate sa computer natin for programmable controllers. So doon ang kanyang effect. Alright. So the fourth type is the power factor, unbalance, and harmonics. This is the fourth power quality issue that we need to understand. Power factor, we already know that this measures the efficiency of our electrical system to supply the useful work. So it is a power quality issue, pero hindi naman masyado kung hindi siya below doon sa acceptable limit. Pagka medyo mababa na, it will become an issue kasi it will create heating problems and other issues on our equipment performance. Unbalanced load, another factor that we need to consider that will affect power quality kasi pagka unbalanced, it will result also to heating. Then harmonics. So electrical loads are often composed of more than just pure resistance. It is the combination usually of resistance and reactance because we are using AC systems. Pero pagka DC, wala tayong ganitong issues because we only have purely resistive load na consideration. Pero in AC system, hindi na DC resistance lang or resistance per se. We also have to consider the reactive power that comes in two forms. Basically, itong inductive reactance and the capacitive reactance. Both of which do not contribute to the useful work of the power system. So kaya nagiging issue siya ng power quality. Wala naman siya contribution pero ginagamit. So this is an illustration on how the electrical quantities work in the system. Pag meron kang conductor, it has the characteristics na composing of two components, resistance and the inductive reactance or the reactance in general. Meron kang supply voltage that will push the current to the system para magkaroon ka ng power sa load. So this resistance or impedance of the system is affecting also the performance of our electrical supply. Okay. So as we have discussed earlier, power factor is a way to characterize how much electrical power goes towards useful work, such as light, heating, or machinery. Now, the low power factor means a large amount of energy is being lost in the system in the form of waste heat, which is generally equates to a higher energy bills and equipment degradation. So, as a simple illustration of how the power factor affects our system. So, meron tayong 1 horsepower load. If the pull of the horse is just purely horizontal, then the entire load carried by the horse is converted to useful energy. But that is not the case in the actual because of the presence of reactances. So meron tayong cases wherein there is an energy required to overcome the capacitive reactance, and there are also cases wherein there is an energy required to overcome the inductive reactance of the system. Because of that, the useful work is not anymore equal to 1 horsepower. Maybe this is around 700 horsepower or 0.75 horsepower or 0.5 horsepower. Depends on the reactance that the horse will need to overcome in order to perform the work required. Tapos na losses. So that's why if you have a very low power factor, it will become a power quality issue. So to illustrate, this is how we draw the power triangle. So the hypotenuse usually represent the power that is equal to the amount of power that we supply to the system in order to produce the real power that is converted to useful work and the power required to overcome the reactive reactance. So that is a reactive power. So ito yung losses. So ito yung input. This will be the real power used for the work. So kung i-illustrate natin yan sa gear, ayan, bula. Ang ginagamit lang natin is yung actual usable energy is yung the beer itself. Itong bula, wasted na, pero buong baso, yun ang nilagyan mo ng capacity, strength. Right? So, why do we have such condition? Now, it happens, as said earlier, because of the presence of the reactants. Now, typically, our loads such as the motors, solenoids, and pumps, it has an impedance combination of resistance and inductive reactance. So, which will vary with the mechanical load on the machine. So, because of this, meron tayo talagang losses to overcome those reactive power required to run the equipment. The other is the capacitors and impedances that are combinations of typically small resistance and larger capacitive reactance. So, meron bang capacitive reactance ang cable? There is. No? Kaysa lang, sobrang liit, it can be negligible. Pero sa mga large insulator na mga materials, it has a very high capacitance or capacity value. At kung meron ang capacitor naman sa system, this capacitive reactance will largely affect the performance of our power quality because it has a higher inductive reactance. So when reactance is present in an AC system, the voltage and current sine waves will shift out of phase from each other. So because of this presence, mag-shift na yung voltage and current natin. Hindi na sila in phase with each other. So, kaya hindi na in phase, there is already a power quality issue. Kasi ideally, as we discussed earlier, dapat they are in phase with respect to each other. So because of the presence of the load components na hindi natin maiwasan because of the property of materials na ginagamit, we have the condition that causes the voltage to shift from each other. So voltage lead the current when it is an inductive reactance. Current lead the voltage when it is a capacitive reactance. Okay. So this is how we illustrate the sine waves of our voltage and current depending on the type of load we have. Pag inductive, voltage is leading the current. Pag capacitive, current is leading the voltage. So this shifting in phase is affected by the reactance of the system. Okay, next we have the unbalanced load. Is it a problem to have an unbalanced load? Yes, it is a problem. Kasi pag ang voltage mo is not balanced, so halimbawa, ang voltage mo is 200 volts and to 40 and to 40, our equipment will not perform effectively. So, when do we see an unbalanced system? So, unbalanced occurs in three-phase power system when single-phase loads such as the lighting, office equipments, and other single-phase utilization equipments do not draw the same amount of current on its phase. Although, wala pa akong nakita na nagkaroon talaga ng system na 100% balance. It is always unbalanced. Siguro mga unbalanced niyan, hindi lang malaki. Siguro mga 10% or 20% unbalanced. Hindi natin ma-perfect balance yung ating load because of the varying characteristic of the loads and its utilization. So hindi man siya magpantay all the time. And then we have single-phase loads. Pagka ganun, it's impossible to have a system that is balanced. So, is that an issue? Yes, it's an issue because the unbalanced condition of the system will create stresses on the other parts of the system. So, in this illustration, for example, if the loads, single-phase loads specifically, is not drawing the same amount of current in each phase, the result is that there will be a neutral current. So, minsan nga, yung usual design natin, for example, the system, or kung minang tayo generator. Generator usually comes with a busbar size na 50%. 50% yung kanyang neutral. The rest, 100% yung mga phases. Now, tanong, bakit hindi lakihan yung neutral size? Kasi naman, ang assumption ng generator is it will provide a constant three-phase na balance voltages. So kung balance ang voltage, there is a minimum chance na magkaroon ng unbalance. This will happen only on ideal conditions. So since the ideal condition cannot exist in a system, mayroon talagang kunting difference yan. The unbalanced current drawn to the system will create a neutral current. Pero, that neutral current, kasi nga maliit lang yung unbalance, it could be tolerable to the system. Pero pag malaki yan masyado, if i-factor in natin ang other factors, such as harmonics and environmental condition and heat, the effect will be different. It can cause stress on the wires. Pwede masunog yung neutral natin, or yung grounding system when the neutral is connected or banded. And to other loads, it can create heating. Kasi pag magkaroon tayo ng voltage unbalance, magkaroon tayo ng unbalanced load, yung voltage drop on other parts of the system could be higher than the other phases. So as a result, pagka hindi naman balance yung voltage mo because of the varying voltage drop, it will create heating to our electrical equipment, specifically the motors. Kasi ang percent unbalance lang allowed for the electric motors is 5%. So anything beyond 5% is not advisable. So kailangan talaga i-balance. Kaya nga, mas maganda kung magkaroon tayo ng equipment na design na kung hindi man natin mabalance yung loading natin doon sa panel board, load side, if you have a three-phase system, kung hindi natin mabalance, meron siyang characteristic to do or perform na pwede niyang i-balance on input side. So that would be a good invention or a good product na to use. Kasi wala pang nangyari na nagkaroon talaga ng utilization, power utilization na perfectly balanced. Okay. So a balanced three-phase four-wire system will have zero current on neutral wire. So if it's balanced, hindi ang case. The amount of current on the neutral wire in an unbalanced system will increase as the unbalance increases. So this could result to overheating and the risk of fire. Kasi nga, unbalanced siya. So the characteristic of the unbalanced load, the unbalanced current will increase in direct proportion to the increase of the unbalance. So habang lumalaki yung unbalance ng current drawn from its phases, the more amount of current will flow to the neutral. So pag na-overload ng neutral, at na-design lang natin siya, for example, sa ating discussion kanina at 50%, it can be overcome, ma-overload. So because of that overload, it can lead to overheating and the risk of fire. So that's why it's very important that after commissioning our electrical system, kailangan talaga mag-load balancing. At least to minimize, not to eliminate, kasi imposibleng ma-eliminate ang unbalance, but to minimize the range of the unbalance in its phases so as to limit the amount of current flowing to the neutral. And also to limit the difference in voltages for the three phases to less than 5%. Kasi if it's more than 5%, it will lead to overheating also to rotating equipments. Motors being driven by unbalanced voltages will result in small motor torque working in the opposite direction. So yung effect ng unbalanced voltage, may magkaroon ng heating because of the small amount of torque working in opposite to the direction of the main torque. So in the opposite direction from the motor rotation, phenomenon known as the counter torque. So in this condition, of course, part of the energy delivered to the motor will work against itself. So this will lead to the poor performance of our electric motor. And if that amount of torque is severe, it can lead to overloading if the driven mechanical load and the motor was designed just sufficiently enough according to the load requirement. Hindi malaki masyado yung allowance, so ma-overload yung electric motor natin. Because of this effect of the counter torque due to unbalanced voltages. Kaya kailangan din magkaroon ng balanced voltage. More than 5% is not good. So 5% is tolerable. Okay, the other factor is the harmonics. Harmonics is a very long topic, pero kailangan natin i-discuss dito in general terms and how it affects the system. So, what is harmonics? Harmonics are type of waveform distortion that occurs in circuits containing semiconductor-based electronics such as lighting, switching power supplies, electronic balance, computers, robotics, equipments, and BFD. So meron tayong mga BFD. Although BFD, meron tayong filtering device niya. Some of the BFDs, merong filtering device, pero mag-create pa rin yan siya ng harmonics because of the operation of the switching na component. So these nonlinear loads impose higher frequency sine waves on the system, so which result in more power loss in the forms of wasted heat. So pag mataas ang harmonics, mataas ang frequency, mainit. Because we calculated the power doon sa ED current loss power proportional to the square of the frequency. So the higher the frequency, the bigger the heat, the larger the power loss and wasted in the form of heat pag mataas ang frequency. So therefore, this is a problem in our system. It is unnecessary and it is a power quality issue that needs to be addressed. Because if we cannot address harmonics, especially the triplet harmonics, this can cause the current to flow to the neutral and will not cancel yung tatlong currents ng VC, VC, VC sa zero sequence. Do not cancel to the neutral. So this will lead to a higher amount of current in neutral and will result to overheating as discussed earlier. So the excess heat produced by the harmonics can have detrimental effects on the power system. So for transformer, especially yung mga transformer na not designed for key factor operation, not designed for additional capacity heat capacity dissipation transformer, if not carried, it will result to overloading. Kasi yung transformer natin magiging derated na because of the harmonics, presence of harmonics. So we have a separate presentation of this harmonics in the previous presentation. Mas medyo mataas na yung if we go deeper into the concept. Pero we know that if our transformers are not carried, its performance will be largely affected. Now, this is due to the heating effect of the higher frequencies. So as a result, if our transformer is not sufficiently or aptly designed, it can lead to damage. Damage in terms of heating, damage in terms of the mechanical impact of the eddy current due to a higher vibration of the iron core. Those vibrations will create heating. And so therefore, if it heats up, its performance is diminished. And if the load is too much for the transformer, it can lead to transformer burning. Okay. So example for unbalance, dito, the voltages are not the same. Okay. So how do we know that there is an harmonics in the system? Harmonics usually identified through the multiples of frequency that it generates. So for example, in our system, the United States at saka dito sa atin, we're using the 60 Hz. The presence of harmonics should give us, for example, third harmonic, 60 times 3 will give us 180 degrees frequency. Fifth harmonic would give us 300 Hz frequency. So if our system has a frequency more than 60 Hz, then that is an indicator of a system that is infested with harmonics. And we know that the contributors to these harmonics are the types of loops that we are connected to our system. So an illustration of how this harmonic will affect the wave, ito yung sa diagram natin. We have a simple wave, sine wave in red. If there is a third harmonic in white, so multiple of that 60, so magkaroon ka na ng another waveform doon sa baba, which is a multiple of the 60 Hz. So para sa noise or disturbance. Now, if you have fifth harmonic, yung fifth harmonic is 2. So pag meron ka ng fifth harmonic is multiple of 5 within the 60 Hz. So as a result, kung meron kang multiple levels of harmonics in our system, as a result, our wave is not anymore sine wave, but a distorted form in yellow. Ito yung magiging result ng wave natin. Now, how does that affect our system? Now, some of our equipment, especially the motors, they are designed to operate in a perfectly sine wave environment or supply. Now, if you have this kind of wave in our system, distortion in the voltage, that will create heating in our electric motor and will diminish the performance. So that's the effect of harmonics. Okay, so if we are going to look at the contents of harmonics in our system, the magnitude will usually vary with the levels of harmonics that we are considering. So basically, ang mas mataas niyan is yung fundamental frequency natin. We have the secondary, third, fourth, fifth, and so on and so forth. So, yung magnitude naman niya, hindi malaki doon sa higher level harmonics. Doon lang sa mga 3rd, 5th, 7th, and 13th, yun yung mataas. So habang tumataas yung level, lumiliit naman yung kanyang magnitude. So if you are going to calculate the total distortion, we have a new term we use to define the magnitude of the harmonic, the equivalent magnitude of the harmonic. We call it THD, or the total harmonic distortion. That represents the total distortion of all the levels of harmonic in our system. And if it is related to power, we also have TDD, or the total demand distortion. So we usually sometimes use it with power quality meters to simplify harmonic distortions as a single measurement rather than an entire spectrum. Kasi pag tayo mag-compute ng effects of harmonics on system, we do not consider each level. We consider only the average value that defines the effect of the entire spectrum of the harmonic system, harmonic in our system. So how do we measure the power quality issues? Okay. So how do we measure the power quality? Actually, meron na tayong instrument na designed to monitor the conditions of our power. So it can tell us, the device can tell us the basic component that we need to know about our system, and it can record, monitor, and can give us report on our power system conditions. So with the use of this instrument, we can determine the power quality. The instrument is what we call the power quality analyzer. So this is equipped with programs, systems that can determine the basic components of all the systems na gusto nating malaman, all of the conditions na gusto nating malaman doon sa ating power system. So may maraming power quality analyzers sa market. Some of those are very expensive, but there are less expensive ones that we can use to address or at least guide us to what we call this one, to assess the condition of the power quality in our system. Ito sa amin, meron kami dito washing, but I'm not recommending for you to buy this one or this is good to the other, but this is less expensive. It's already a good tool for us to use in assessing our power system quality. So what do the power quality analyzers will give us? So number one, it will give us real-time measurement. So you can measure the wave, you can measure the harmonic, power, energy usage, voltage levels, voltage imbalance, real-time, kita natin sa ating power quality analyzers. Yung power quality analyzers, simply, it's just an instrument that measures usually the current and the voltage of the system. And then from those readings, meron siyang program, software na pwede yang i-segregate yung conditions na gusto nating malaman sa system. So ito yung kanyang mga components. CT, we have the voltage sensors, and we have the instrument. Okay. Aside from real-time measurement, we can also monitor the trends of the system. So we can also get alarms, we can also get transients, measure transients. I-set na natin yung value ng transient level na gusto natin ma-measure para mag-trigger siya. Mag-trigger siya, we can capture those information using our power quality analyzer. Then we also have the transients. We can measure the transient, the inrush current, and we can have snapshots of those informations in snapshots of those informations and be saved in our device. So basically, ito yung device natin. Meron siyang mga functions, 6 functions. Ito, it determines the wave, the real-time measurement for the voltage, current, power, and harmonics. This represents the harmonics. This one represents the transient and inrush currents. So the program. Then we have the trending. So trending, kailangan din program. What are the factors that we need to know? Or what are the elements or what are the the quantities with regards to our power system that we need to monitor for a certain period of time. For example, 1 week or 1 month measurement, kailangan din i-trending. We also have the capture setting. This is where we set the parameters that we are going to measure, then save. Then here W is we can measure the power energy consumption. Then we have the spectrum of harmonics, current, voltage. Ito yung kanyang file. So, how do we connect the power quality meter? Usually, natin yan sa system. If it's a 4-wire system, in the program, meron tayong method din to determine the type of system that we are going to measure. So, pipiliin natin yan. In this case, meron tayong 3-phase 4-wire system plus earth. Ito yung kanyang connection. So, meron ng 3 phases, line 1, 2, 3, and the neutral plus the ground. So, using our CT, we measure the phase currents, the neutral current, as well as the ground current. Then you also put the measurement for the voltage sensors in its phases, the voltage to neutral, and the voltage to ground, to earth. So, yun yung kanyang connection. So, after connecting, meron tayong iset for the quality. We can get the real-time measurement, the power, that includes the wave, harmonic, power, and energy, including the phase sequence. So, a power quality meter can plot the voltage and current waveforms as a function of time. So, this is called oscillogram. Now, there are types of power quality meters or power quality analyzers that has more advanced settings that can give us a better view on how our system behaves para magamit natin in addressing also the issues. So data can be extracted from the power quality recorder and analyzed to determine the overall condition of the power system using various time plots and tables. So kung mas maraming information, siyempre mas mataas yung storage na kailangan. Pero kung mas marami din tayong information na kukuha, marami tayong parameters na nasusukat, mas maganda rin yung assessment natin na magagawa doon sa ating system. And we can further improve our system using those information. Okay, so the actual data analysis is usually performed by analytical engineers, of course, kasi tayo yung mayroong deeper understanding on how the system behaves and how we can use those information for improvement. We will generate a report and provide summary of the various power conditions of the system. We can list the events that occurred during the analysis and any corrective actions or recommendations that should be considered. So, yun yung gagawin natin. So, ito ang example sa illustration natin sa power quality meter natin. You can see the wave. So, sine wave, kita din natin yung kanyang phase sequence. So, sa wave, real time, nakita natin yung kanyang sinusoidal waveform. Perfectly sine wave ba siya or mayroong distortion, makikita din natin. So, wave, we can also see the magnitude of the voltages. So, ito, mayroong unbalance. If it is more than 5%, that is already an issue. Then makikita rin natin yung time for the peak voltages to occur the system. So, meron tayong voltage dyan na umabot ng 484, 492. Define niya, merong 8.3 milliseconds na transient. Ito yung occurrence sa mga spikes. Kanina, na-define natin if it is sags or swell, sabi natin it should be 8 seconds or 8 milliseconds sa system. So, ito, kita natin meron sag ng U1, meaning line 1, meron namang swell ang dalawa, U2 and U3. And also you can select the RMS, the total harmonic distortion, and other information such as the phase voltage, line voltage, and current, or you can measure also or get the information of just the line current of all the phases. Then on the other end, you can also get to see the phase sequence. Ito are RYB. So this is clockwise. RYB. Yung kanya phase sequence. So this is also very useful in, especially if you are doing the commissioning of the system. Meron kang motors, 3-phase, tapos bago yung switchgear mo or bago yung generator mo. Before connecting, you can do power quality analysis on both ends para makita natin yung kanyang initial condition sa system. So those are the things that our power quality measure, power quality analyzers can do. So makikita niya phase sequence. Yan. And also, you can generate information on the harmonics, harmonic contents. So dito sa kabilang side, kita natin yung kanyang DC component. In terms of volts, maliliit lang. Total harmonic distortion of its phases. This is for the voltage. Merong 2.3, 2.7, and 2.7 in terms of percentage. Makita din natin yung kanyang I forgot this DF. It's a Christ factor naman itong CF. The Christ factor is a factor that will define if our voltage waveform is purely sine wave. So dito makita natin yung kanyang Christ factor is 1.45. So meaning hindi siya sine wave. Kasi Christ factor natin kung purely sine wave is 1.4142. Dito 1.45. So this is an indication na mayroong harmonic system. Pag hindi siya ideal, hindi 1.4142 ang kanyang Christ factors, 1.45. And also we can generate the graph for the harmonic spectrum from level 1 up to 50. Mataas na masyado, kaya maliit yung ating screen, can only reflect up to 25. Pero maliliit naman yung mga values nila in order for us to consider also the assessment. So, yun yung makikita natin sa ating power quality analyzer. This is for the voltage. You can also pick the VA, amperes, and the voltage, phase voltages. Yan. So, power quality meters are capable of calculating large number of power measurements at extremely high speeds. So, these measurements includes the minimum average, maximum values for the parameters such as current and voltage, phase relationship of waveforms, power factor and frequency, active power in kilowatt, active power in kVAR, power in kVA. It can also measure the active energy in kilowatt hours. So ito na component, pag nagamit mo na maganda, na setting mo rin na maganda, then you can use this one for power improvement or expansion in the future, or you can use it for your information in designing a solar system. Meron kang information sa kanyang usage, so you can design the solar system. Pwede rin ganyan. Kung magkaroon ka ng bagong expansion, you can get the energy use profile, the data doon sa system mo, sa power quality analyzer. You can have a very concise assessment of the system on how improvements are to be made. Then it can also give us the harmonic spectrum, both the TSD and the PVD. So ito yung kayang gawin ng ating power quality analyzer. Okay, so for the monitoring, kasi kailangan din ng power analyzer, yung parameters natin na kailangan i-click. For the recording, you can click the line voltages or supply voltages, RMS, load voltage VRMS, current load RMS. You can also pick the watts or the energy or the power usage in watts, the power factor, then the harmonics, voltage and current up to 50th level. And also you can pick the THD of the supply voltage or the THD of the phase voltage, and then the THD of the current. You can also pick in the bars, power factor, tangent theta. You can also get the Christ factor of the line voltage, the Christ factor of the phase voltage, and the Christ factor of the current. So this will help you define if the system is working ideally or not ideal. You can also record the VA consumption. And you can also record the unbalanced voltage of the line and the balanced voltage of the phase and unbalanced currents. The key factor, if we are considering treating the harmonics of the system or improving our transformer, converting into key factor or key rated. Also, this will help us design our, if we have capacitor filters, capacitor banks, this information will help us. Then we can also get to record the PST, that is the flicker system and the frequency. So all of those can generate a waveform na ma-save sa ating computer for all the information for a certain period of time that we want our analyzer to do. So ito yung sa trending makikita natin. Okay, so what are the waves that we can get? For example, dito, kita natin dito, measurement natin. As an illustration, dito sa facing tayo sa monitor, meron tayong picture dito sa left side, topmost. Kita natin yung kanyang interruption or nagkaroon ng power voltage ng phase C. Nag-drop to 0 volts from 246 from 293. So, na-record niya yon for siguro mga 1 hour. So, nagkaroon tayo ng phase loss. Nakita natin yung phase loss ng ating system. Na-measure niya, na-detect niya. Then we can also measure the variation of the harmonics in the 3 phases sa picture number 2, right side, topmost, wherein we can get the maximum and minimum values. Yan. Then we can also get the voltage variation for the whole time nagkaroon tayo ng measurement and monitoring. So makikita natin how the voltage changes with respect to time. Yan, kita natin variation here. Then also we can record the unbalanced voltages. So that is just an illustration of the capability of our power quality analyzers. Then we can also get the total harmonic distortion of the current sa load natin. So makikita natin yung behavior ng ating load on its phases. So makikita natin yung phase A, phase B, and phase C. Kung sino sa kanila ang may mas taas na harmonics generated. So from here, we can use it, or we can use this information to evaluate how to address the problem on phase C, phase A, and phase B. Kita mo yan yung conditions niya. Then we can also get the load profile showing the consumption for the whole period of time na ginamit natin yung device. Ito yung energy spectrum. Makita natin yung kanyang consumption, yung variation ng kanyang power consumptions for the entire period of time na ginawa natin yung measurement. Nakikita din natin yung magnitude niya in terms of watts and the magnitude in terms of kVA. So from here, you can design, or you can use this information for doing some improvements on the system. Yan. Okay. So another thing is that it can register or it can record the flicker. So nakita naman natin yung system na kinabitan natin is medyo maganda yung kanyang performance except for the yellow phase, or that is line 2, no? At saka yung phase B, merong fluctuation konti, flicker. So it could be, since single phase lang siya, it could be a single phase load affecting this distortion or this variation rather. So parang regular ang kanyang appearance sa yellow. Then sa blue naman, umakyat na konti. So from here, we can trace what are the component or load that affects this performance of the system. Then we can also record the power factor, how the power factor varies. Pag magkaroon tayo ng power factor improvement measures, makikita natin yung kanyang behavior throughout the entire period of measurement. So makikita natin yung pinakamaliit, yung pinakamalaki. So from that, we can project the right size of capacitor bank or filtering device na pwede natin gamitin sa ating system if we do mitigations. Okay. What else? So, yun yung kanyang magawa, no? Then, makikita din niya yung kanyang sums, well, and the interruption. So, yan, kaya natin i-project. So, how do we use? So, what can we get from the report of our power quality analyzers? Of course, we can equip ourselves with the methods of mitigation that we will be implementing kung meron na tayong information of our system, how they perform. So, kung meron tayong sag, swell, or interruption, we can equip our system with the overvoltage protection for swells or interruption. We can equip it with under voltage protection for sags. And if there are phase loss, example doon sa ating illustration na nakita kanina, we can protect our system from phase loss also. Kasi yung phase loss, pag isang phase lang nawala, there are transformer that will create the ferroresonance condition pag magkaroon ng phase loss. Matanggal yung isang phase, magkaroon ng ferroresonance that will result to overvoltage on the secondary side. So pag wala kang protection of phase loss, hindi siya ma-interrupt or hindi siya ma-turn off during the occurrence of the phase loss. So mamaaring masira yung equipment mo doon sa downstream. And another thing, I think, is that we can put voltage stabilizers. We can size up our voltage stabilizer to address the power quality issues of interruption, sags, and swells. So, yun yung makukuha natin sa report. Or else, for the flicker, pwede natin lagyan ng mayroong flicker at saka transient o mayroong noise. So, pwede natin lagyan ng SPD or source protection devices or TVSS naman sa other brands, transient voltage suppressors. Kasi we have information on the transient condition, the flicker, and the noise of our system. We can also design the snapper circuits to eliminate the noise, or we can equip our system with the aptly designed EMI or RFI filters kung meron tayong ganitong mga noise sa system. So, kasi we have the information. Alam natin kung anong solusyon na kailangan. Kung nandoon naman tayo sa mga harmonics problem, at saka unbalance, power factor, we have the information that will help us to address those issues. For example, kung single phase loads natin unbalanced, we can redistribute the single phase loads. Kasi yung information na yun, nakikita natin doon sa ating power quality analyzers, kung saang load medyo mabigat, saang load lightly loaded. And if also we have the worst power factor condition of our system, we can implement the installation of the capacitor banks. Alam natin yung tamang size. Then, if we have the information about the harmonics, we can treat the harmonic contents by system. Kasi alam natin yung ano yung prevalent harmonic sa system natin using our power quality analyzer. So, we can treat them using a delta-delta transformer or the delta-Y transformer, or we can use an isolation interface, or we can use the line reactors depende sa condition ng harmonics natin, or you can have shunt traps or harmonic filters. So we can size our mitigating equipment effectively if we are equipped with the ample information of our system. So pag mas marami tayong alam na information sa ating system, we can better address the issues with the right equipment na pwede natin gamitin. Okay, so yun yung advantage of having the information from our power quality analyzers. Okay, so standards. Maraming standards. These are the standards that will help us understand the science behind monitoring and correcting power quality. So merong ANSI C84.1, IEC 61000, IEC 519. This is for the harmonic control. In one of our presentation na point natin ito na information. Then IEEE 1159, IEEE 1250, IEEE 1668. So this will give us the recommended practice for the voltage sag and swells. Na-discuss natin kanina, it should be not more than 10% or not less than 90%. Then we have the IEEE 1789, recommended practices for modulating current in high brightness LEDs for mitigating health risk to the viewers. Ang mga LED TV, paano natin i-address yan? Ang lagyan natin ng mga TVSS or noise filters or transient suppressors. So ito yung mga recommendations natin for the standard of power qualities. So meron tayong isang illustration dito, no? ginawa nating power quality analysis. A very simple report. Nagkaroon ng problema ang client and they wanted to assess the condition of the system. Ito yung information na nagawa natin. This is just an illustration of the report kung paano natin gamitin yung knowledge natin about power quality and how to address those power quality issues. Okay, so introduction, for example, dito sa report na content, this is just a suggestion. You can have your own, and then you can develop your own method. Also, the information that we need to record, to trend, para magamit mo in assessing. You can have your own, depende sa instrument na gamit. So here we have the purpose, the background, the scope, the discussion, parameters, settings, ginawa natin, the voltage and time plans, current and time plans, power, energy, and load profile plans. Then we have the interpretation, findings, and evaluation. Then we have the summary, recommendation, and conclusion doon sa ating ginawang report for power quality analysis. Ito yung purpose. The purpose of this report is to assess the power quality physically. In the background, there was a problem in the facility that caused them to hire the technical people to do the assessment. So they have the problem, common failure of the equipment. Parang nagkaroon ng failure. And this failure has not been addressed for a longer time. So kailangan nila malaman kung ano yung dahilan. So to root out this problem, we recommended the power quality measurement. It was requested by them. Ginawa naman natin, we offer them the services. So the purpose is to eliminate the problem and avoid or eliminate the recurrence of the problem. And then in the future, save cost of operation. Kasi yun nga, hindi maganda yung power quality natin, it could entail loss in cost. In the scope, the report covers the PQE measurement, the analysis, evaluation to identify the root cause problem using the following criteria. Supply voltage, ito yung ginawa natin na CT. Kuha natin yung supply voltage, load current, harmonic, and the load use profile. So other matters not cited are therefore excluded. So ito lang yung ginawa natin yung report. But you can extend the amount of information that you want to include sa power quality analysis by programming it to your PQA. So ito na yung ating data gathering na ginawa. You do the measurement and some definition of terms. Ito yung sequence ng ating problem-solving strategy. We are going to evaluate all the aspects from materials, equipment, system, methods, and people involved in the operation that caused the failure. And then we have put the parameters of the system. So ito yung ginawa natin mga parameters for our device to monitor, to help us evaluate and assess the system and provide us the information on how to address the issue effectively. Yan. So ito yung measurement na nakita natin kanina. So nakita natin mayroon ng instant na nagkaroon ng phase loss. Mayroon ding instant na mataas yung unbalance during the time of measurement between 5 to 6 p.m. So ito yung nakita natin. For the voltage naman, imbalance is within 5%. So tolerable kasi yung standard naman is around 5% below. Okay lang yan. More than 5% is a problem already. In here, sa nakita natin ng measurement, the real problem was single phasing, incident. Or nagkaroon ng phase loss. So what causes this phase loss incident na system? Yun yung gusto natin malaman. Why is it dangerous? Why is it a concern? Because this can create ferro-resonance condition that will restore to increased voltage. And if not addressed well, this will damage our electronic equipments connected to the load side rather. Kaya kailangan natin ma-address so mayroong interruption. It could be a system generated sa utility mismo or it could be doon sa loads natin. So yun ang kailangan natin malaman. Okay, then also have measured the voltage and time plans. Very minimal naman ang kanyang variation sa RMS voltage. And the distortion naman is within the limit na 5%. Kasi nasa mandate ng IEC 519, at least 5% for the voltage and the current. So this is within the tolerable level, so therefore it's not an issue. 4.7% lang. And the voltage level is within 4.7%. So walang problema doon sa voltahe so far sa system. So nagkaroon lang tayo ng problema dito sa single phasing incident. Then considering the load harmonics, ito yung nakita natin sa load harmonics, may umabot ng 8.5%. May umabot ng 13%. So mataas ito, 13.4% sa mataas. So this is a concern because the mandate of the distribution code is to have 5% harmonics both on current and voltages. So this is an issue. So meron tang mataas na harmonics yung ating load system. Kaya there was a problem. This can cause overcurrent doon sa mga capacitive loads, undercurrent naman doon sa mga inductive loads, and heating doon sa electric motors natin. So those are the problems that we see. Then you also measure the load profile of the system. We find out that it's regular for several period of time. Now, considering the load reuse profile, maximum demand of the system is only around 372 kilowatts occurring during the first hour of the morning, and the minimum demand is 164.7 kilowatt. Now, this information will help us also design the mitigation strategy that we are going to apply, both in terms of renewable energy and yung distant power system kung magkaroon ng interruption. So ito magamit natin. So the average demand for the whole 24 hours is about 240 kilowatts. So the apparent power demand on this condition is 453 respectively. So nakita namin na the transformer is malaki kumpara sa kaniyang capacity. So this will lead us to conclude na tama lang yung equipment size, and there is a very rare condition na magkaroon tayo ng under voltage system. So which can cause the damage of our equipment. Yan example. Right. Power factor also was measured during the time. Nakita natin there is a room for improvement. So in terms of efficiency. Okay, so all in all, kita natin yung prevalent is single phasing problem. So identify natin that this could be the root cause of the frequent equipment damage and the harmonics. So nagkaroon tayo ng recommendation for this to address the problem. They are going to protect the system from single phasing or from power outage by providing protective equipment on the high side of the equipment or the transformer. Para pag magkaroon ng single phasing, our equipment will turn off and the generator and other sources of power can be activated para ma-avoid natin yung problem that leads the cause to damage our equipment. Then, to address the harmonics also, we recommend to install filters and other method. Now, in general, as a conclusion to this report, in order for us to analyze or assess our power system quality, we need to have equipment that is capable of measuring the parameters of our system that will provide us the ample information on how to address those issues na na-observe natin occurring in our system. So without it, wala tayong information, without the knowledge on how the system behaves, we cannot provide the suitable solution that will fit and that will address the issues that we are trying to solve. So that ends my presentation today, and good afternoon.
Thank you, Engineer Estrella. Marami na pong questions dito from our participants.
Okay.
From Engineer Roberto Ocampo. What is the penalty for the DU if their supply is not complying with the distribution code?
Sila kasi mayroong penalty yan as defined sa Philippine Distribution Code to pay the clients for the poor power quality na they-produce. Kaso lang, ang lusot na nila dyan is voltage 10%, plus or minus 10%, hindi naman sumusobra sila dyan. Pag walang issue doon na more than 10% yung more than 10% plus or minus, it could be either more than 10% yung kanila na sinusupply. So lusot sila. Tama pa rin doon sa compliance yung kanilang ginawa, sinupplynable time.
Another question po from Engineer Ocampo. What is the current reading of the power interruption that will increase demand charge of customers because they have to restart all their loads immediately, unlike the planned energization?
Depende yan depende sa utility company. Tayo kasi sa Manila, mayroon demand charges sila. Dito sa Davao, wala kami ganong klaseng charges, demand charge. Pero siyempre pag interruption, malalaki yung equipment mo, the higher the demand, the better for the utility company. So, maaari lang sinasadya or hindi naman natin sinasadya. Pag pagkaroon ng ganitong interruption, pagbalik ng system mo, you have to consume much power during the startup. So, malaki yung demand, mas mataas yung bayad. Kasi meron mang demand charge. So, for utility companies with demand charge, this will have a great effect on their billing kasi mas mataas yung demand. So, sa kanila ng mga areas na mayroong demand charges, dapat ang gawin natin sa client side is to control the switching on of the electric motors to limit the demand during startup para i-program natin yung sequencing ng operation para pag brownout, control side natin is to limit the demand. Mas maliit yung demand, mas maliit yung babayaran natin. Kasi habang lumalaki yung demand, mas tataas yung natin, tataas yung electric bill natin.
From Engineer Rene Olamit naman po. Of all these manual calculations, can we cross-check this power quality analysis to equipment simulators for recommended testing in software applications?
Hindi ko na medyo po to. Sige daw.
Of all these manual calculations, can we cross-check this power quality analysis to equipment simulators for recommended testing in software applications?
Yes, meron namang ganyang klaseng mga software na pwede mag-assess, simulate. Pero this one is ideal also, ideal condition. Kasi pagka simulation, it is an ideal condition pa rin. But there are software program that can assess the condition of the system through using the simulation. So makikita natin yung behavior niya. We can simulate. So hindi natin i-calculate manually, but we can simulate it using a software. But that is the expensive way of doing it.
Another from Engineer Rene po. How can we integrate this power quality analysis to all of those PER required engineering principles such as short circuit analysis, voltage drop analysis, arc flash analysis, motor current protection, and etc.?
Ang power quality analysis, magamit natin siya not for the short circuit. Kasi ang information that is being provided to us are just merely the current, voltage, power consumption, harmonics. So this information will help us to design on the protection. Para sa protection, yes, it can help for mitigating measures. Halimbawa, magkaroon ka ng design for capacitor bank, you can use it for the capacitor bank design because you have the information, and voltage drop calculation. So you can use it for the voltage drop kasi makikita mo man yung actual consumption, actual pag-drop, pag-rise ng voltage using the instrument. But on the short circuit, it can be, it can help, pero there is an information na pwede natin magamit in calculating the short circuit. Pero basically, sa tatlo lang natin pwede gawin, magamit siya. Yung voltage drop, yung sizing ng capacitor bank, at saka yung sa protection. Excuse na nga.
From Engineer Nathaniel Torrena, Sir, ilang percent ang acceptable unbalanced load for 3P system? At kung
As discussed kanina, mga 5% imbalance number.
From Engineer Rosana Frias, is there any threshold for unbalanced load?
Threshold, yung 5% natin na na-discuss.
From Engineer Darwin Gabino naman po, ranging how much po yung equipment?
The price, it depends on the brand. Itong ginamit natin is less than $1 million lang. But it can already give us the information for assessing the system. Pero may iba, magandang quality, hindi ko lang siguro sabihin ng mga brand. Full day siguro, mga more than $1 million, from 800,000 to more than $1 million.
Sino yan?
Saan po ba?
From Engineer Ariel Pineda naman po, why other company prefer branded PGA test equipment in doing power quality measurement like System On?
Kasi babayaran nila, di ba? For example, if you are a third-party service provider, tapos gagawa ka ng analysis or assessment doon sa client, if you have the best equipment, mas mahal yung equipment mo, mas mahal yung charges, and that is also affecting their decision, yung cost. And they are just after knowing if there are things to be addressed doon sa system nila. So basically, they prefer yung mga equipments na hindi naman high-end that can give them the helpful information to help us, or to help them rather, find the solutions for those problems. So merong mga mura pwedeng gamitin. The same amount of information na makukuha natin, pero hindi sila matcha-charge sa malaki. And that is, preferred nila yan na kunin of the services. Kaya we look for that also. Tinitingnan nila yung gastos nila.
From Engineer Leody Diaz naman po, any idea why naglalagay ng AVRs, elevators, sa high-rise buildings sa Metro Manila? Di po ba ang usual problem ay search due to light?
AVR is, ang elevator kasi is sensitive. Some elevators will only limit the voltage fluctuation of 5%. Meron pang iba, 3% lang. So because of that, we have a 400 volt system. Tapos marami tayong single phase loads. There is a higher chance na magkaroon ng voltage imbalance. The voltage fluctuation, sag or swell, more than 5% or more than 3%. So because of that, kailangan nila i-maintain yung output voltage na nasusupply sa elevator para hindi ma-damage yung kanyang equipment kasi very sensitive, voltage sensitive yung mga elevator equipment. So that's the reason why they are putting EVR as one method to address the low power quality issues that may arise kung mataas na yung occupancy ng building. Kasi yun yung magiging problema. Yung TBSS naman is the protection of the electronic component, yung mga insulation sensitive equipment na maaaring ma-damage sa elevator. Kaya naglalagay din tayo ng TBSS para hindi rin sisirain yung ating mga electronic equipment na sensitive to transient. But in most cases sa elevator, hindi sila naglalagay ng ganyan kasi ang treatment niya, usually the elevator is to ensure the voltage. Tapos yung sa transient is doon sa kanyang utility, sa supplier, sa electrical component, sa substation. So doon nila tina-charge yung treatment. So that's why requirement ni service natin nung sa substation is to have the TBSS prior doon sa connection ng elevator equipment.
Okay, galing naman po kay Engineer Greg Rasco. Ano po yung recommended time duration ng connection ng power quality meters sa system during testing?
Depende sa amount of information na kukunin mo. Kung gusto mong malaman ang energy use profile, dapat magiging regular yung measurement. So, 1 week. Kasi di mo makita yung profile if you are going to measure the 1 day consumption only. Hindi naman natin alam yung usage. Baka sa Monday, lightly loaded. Tuesday, biglang umakyat yung load. Tapos pagka Wednesday naman, medium lang. On the other days, hindi natin makikita yung spectrum. So, 1 week is a good duration for the measurement para makita natin yung kabuuan ng operation ng ating system. That will help us a lot how the energy is being used in the facility.
Galing naman po kay Engineer Randall Nakatay. If previously the THD was less than 5%, without any change of loads, it increases. What particular factors affects this phenomenon?
Usually kasi ang THD is a property of our load. No? The other is the property of the system. So, for example, si utility company, kasi they are also limited by the distribution code. Dapat 5% lang sila. So, for sure, they are making sure 5% lang yung nilalabas nila. So, sa load side mo, if there are no changes, it could be related to some other parts ng system natin. For example, yung transformer, meron ng nag-flicker sa transformer, meron ng insulation failure, mayroon ng mga partial discharges. Yung installation mo, mayroon na yung mga partial discharges. Yung mga breaker mo, for a longer period of time, hindi natin na-assess yung kanyang condition. Mayroon ng mga alikabok, yung mga termination natin pinapahigpit. Mayroon na siyang tinatawag na partial discharges or transitional switching or mayroong mga incidents na nagkaroon ng flicker. That will affect the condition of the harmonic system. Kasi pag magkaroon ka ng on-off or mga sudden changes ng voltage due to the discharges, mag-create man yan ng wave kasi parang switching. As defined earlier, na yung harmonics is caused by the switching of the device. So yung flickering ng equipment mo due to insulation failure, yung transformer, yung terminals mo, nagkakaroon ng sparks, that will also add to the generation of harmonics on the load side. Kaya malamang, kailangan mo i-check yung condition ng LVSG mo or NVSG, baka nagkaroon na ng partial discharge, yung wire mo, yung mga higpit, yung termination ng mga lugs mo, baka nagkaroon na ng gaps, nagkaroon na siya ng intermittent switching or intermittent arcs, that will generate harmonics. So, pagka ganun, wala kang binago, mayroong nangyari, you have to check the physical condition of your system. So basically, yung partial discharges, yung termination, yung insulation condition, at saka yung condition ng transformer. It could be that factors are affecting why harmonic of your system is increasing.
Follow-up question po from Engineer DPS. Di po ba dapat yung controller lang ng elevator ang lalagyan ng APR?
Ang controller kasi is ang power supply ng elevator is kasali doon yung kanyang controller usually sa input. Kung kaya nating hiwalayin ng grupo, kasi electric motor lang naman talaga yung elevator. Kung kaya nating paghiwalayin yung dalawang component na yan, it could be done. Controller lang i-address mo para maliit yung size ng AVR. Pero in most cases, ang elevator natin na built-in yung kanyang controller doon sa kanyang supply, hindi siya nahiwalay. That's why, whatsoever is the size of the elevator, gano'n na rin yung size na nilagay doon sa buong equipment mo na AVR size. Natin si sarili na yung i-consider lang natin yung controller.
From Engineer Vincent Edison Malagreño. Clarification lang po regarding THD acceptable limits. Sa Philippine Distribution Code po, what is mentioned is only TDD and voltage THD. Where do we find the current THD? Do we really need to address this if the voltage THD and TDD is already in acceptable limits?
Ang nakamandet kasi both current at saka voltage, 5%. So that's why if it's beyond 5%, ano na yun? Yun na sa compliant doon sa code. So it's either the voltage or current. TDD, THD, it's always 5%.
Follow-up question po from Engineer Ocampo. What if below 10%? I think ito po yung sa first question.
Ano yan?
Yung what
Ano
if,
yan?
yung question niya po na yung what is the penalty for the deal. May follow-up question po siya na what if 10% below.
What if 10% below yung siguro yung sa ano yun, sa voltage no, expectation, ba? Hindi ko na alam yung specific na ano niya. Pero ang penalty is magbabayad sila ng ano, magbabayad sila sa client nung charges for not supplying the right amount of voltage. Baka voltage ito sinasabi niya kanina, voltage limit of 10%. Magbabayad sila kasi losses on the side of the client. Nagkaroon siya ng losses kasi mayroong heating. So, that losses will be babayaran ng LIU for not providing the right amount of voltage na beyond the mandated 10%. Pero I'm not have the specific ruling how they are going to pay the charges, pero meron silang babayaran niya. Siguro we can answer that one in a separate siguro by through email na lang to get you the specific conditions for the payment kailangan bayaran.
From Engineer Leonie Diaz po. Kasi BBBF ang motor elevator. Then, written po ba elsewhere yung 5% for elevators? I have not read this in ASME or EN 81 standards for elevators.
Usually, supplier requirement o mandated na value. Could not be more than that kasi masisira yung equipment nila.
From Engineer Rene Olamit, can we blame the surge voltage kapag it always burned out the elevator AVR? What is the best recommendations in order to prevent the same scenario? What are always calling the elevator vendor to sort out this problem as it is?
Board out is transient or over voltage? Wala nakalagay, no? Ang burnout kasi ng it could be, ang AVR kasi, we size the AVR, we consider the voltage extremes. So, ano yung pinakababang voltage na kaya nang i-handle for the same amount of current? And ano yung pinaka-maximum amount of over voltage na pwede na i-cater na hindi pa rin siya nasusunog. So basically, yung sizing ng sizing ng AVR natin is based on the lowest voltage na pwede niyang tanggapin sa system without being damaged, the lowest voltage. So, pinakababa. So, kung pinakababa yan, simply, by the calculation, the basic formula ng voltage, current, and impedance. If you have a very small voltage, current will be higher. So, pag higher ang current, if your EVR is rated only, for example, 100 kVA or 100 kVA para mas madali. Tapos, that is for 400 volts, 100 kVA. Tapos, yung elevator mo naman is 100 kVA din. So, assuming na walang fluctuation sa voltage, 400 volts lang, walang problema yung 100 kVA mo. So, hindi siya masusunog. Now, here is a problem. Magkaroon ng voltage sag. Halimbawa, umabot na ng 80%. 80% na yung kaniyang voltage. Bumaba siya. So, under voltage. So, 80% of 400, for example, that is equivalent to 320 volts. So, nang 320 volts na yung load. Your AVR is not anymore capable of handling the heat generated by the load. For a 100 kVA at 320 volts. Kasi yung design mo nasa 100 kVA tapos 400 volts. So, undersize na siya. Umangat na tayo ng 125%. So, ang ample size niya dapat 125 kVA na. For the same amount of load, undersize na yung 100 mo. Kasi nagkaroon ng under voltage condition. So, it could be a capacity selection or sizing issue. So baka hindi na size ampli, kaya nasusunog yung EVR if the voltage quality problem was the issue. Pero kung transient, that would be another. Kasi init yun eh. Pagka transient naman, iba yung init niya. Kahit na 100 kV yung rating at 5% is the halimbawa, tapos biglang umabot ng harmonic, umabot ng 10%, 50%, overloaded na siya due to heating. So kaya nasisira yung EVR. So that's why we need to know what is causing the problem. So ano yung nag-cause ng nagkaroon ng ganyang klaseng failure? So here comes the power quality analysis. Kaya doon natin papasok yung power quality analysis para ma-address natin specifically, ma-identify natin yung root cause and eliminate natin yung problem. So yung proposition ko kanina na it could be an overvoltage or undersize, di ba natin alam yung actual condition, but it could be the reason nagkaroon ng undervoltage at undersize.
For our last question po, from Engineer Eric Budroy, is it common to utilize positive or negative 45% voltage input range for AVR in data center? What is the industry standard?
Well, that's very, very high, plus or minus 45%. 45, no? In terms of capacity? In terms of capacity ba ng voltage or in terms of capacity ng power? Kasi ang voltage natin, ang EVR usually is working between, if you are talking with EVR, it is working between 5% to 0 to 5% rather. Pero kung capacity, nasa atin kasi ang load ng natin, pagka call centers or data centers, mataas harmonic yan. Ang correct method na para makalculate natin amply yung size ng ating EVR is to use the K rating, the equipment. Then we calculate the size of the EVR using the K rating value. So yun yung basis natin. Baka naman yung 45% magiging sobra or baka naman oversize natin, di ba? So hindi rin maganda kung oversize or di rin maganda kung undersize. So to size it properly, gamitan natin yung K rating. Identify natin yung harmonic distortion that the system will generate, and from that we calculate the amount of the rating sa ating EVR, and then we base our sizing of that EVR on that calculation of the rating para amplify yung ating EVR.
From Engineer Jimenez po, kindly clarify the 5% limits applies only to voltage distortion. Current limits depends on the MVA short circuit or the current short circuit per maximum current demand. 5% distortion limits at 1 kV to 69 kV.
Yes. Mayroong calculation na which we discussed in power system harmonics. So may yung specific value. Tama.
I think yan na po yung last question na may entertain namin since we have more topics to be discussed. And with that, allow us to award the Certificate of Appreciation to Engineer Estrella. This certificate of appreciation is presented to Engineer Dennis R. Estrella for imparting valuable insights as technical resources speaker on the topic Power Quality Analysis during the IIETC Chapter Technical Caravan, the MMR Marathon of MWC, held on August 20, 2023 via Zoom conferencing. Signed by Engineer Joseph Darren Claire SLR, Engineer Alberto R. Herrera Jr., Engineer Catalino E. Rania, and Engineer Lyndon R. Bague. Thank you, opening argument for both.
Thank you.
Sir.
Thank you very much. Thank you.
Thank you po. And for our next topic, which is ANSI vs IEC short circuit analysis, to help us all welcome our next speaker, may I call Engineer Rolando Yamsuba.
Magandang hapon sa inyo lahat. Nadidinig mo ba ako?
Yes, clear.
Okay. Yung